Hello everyone, I am Srinivasan from RMD Engineering College. In this video, I'm going to talk about K Medoid's clustering algorithms. K Medoid's clustering algorithm is also called as partition around Medoid algorithm, that is PAM. It is proposed in 1987. Here, the Medoid is defined as the point in the cluster, and its dissimilarity with all other points in the cluster will be minimized in this method. The similarity as well as dissimilarity between the Medoid point and all other points in the data set will be calculated using some distance measures. So this formula is used as for calculating the cost of the cluster. Look at the important steps of the algorithm. First step is initialization. Here, the k random points out of n data points in the data set will be taken. Then it associates each data point to the closest Medoid by using any common distance metric methods. It continuously decreases the cost till there is no more swap possible. So for each Medoid, it takes the each point, which is not a Medoid. Then it swaps the Medoid and with the non-Medoid point if the point the point minimize the cost of the cluster. So this diagram shows the important steps of K Medoid algorithm. First, we take the data set, then we randomly select K Medoid as the input. Then we measure the similarity between the Medoid and non-Medoid points. So based on that, we form the groups. See, after that, we select some other Medoid points and go again, we calculate the cost after forming the clusters. If the cost of the yearly formation is less than the cost of clusters in the current formations, then we reverse the swap. So we retain the earlier Medoid points. See, let us understand the steps of the K Medoid using the following example. We take 9 data points. Out of 9, we take the point 4 and point number 5, point number 9 as the Medoids. Then we calculate the cost using the Manhattan distance formula. We select the non-Medoid points and calculate the dissimilarity between the Medoid and the non-Medoid points using the Manhattan distance formula. See, after that, we tabulate the results. So all the similar points will be grouped, okay, to the nearest Medoid. As a result, point 1 to 5 will be placed in the first cluster, and the points 0, 3, 6, 7, and 8 will be the member of the second cluster. Then we calculate the cost. So the cost of the first formulation is 20. Now we select 2 other random points as the Medoid, and we find out the distance between the new Medoid and other non-Medoid points. Okay, then they again form the groups. See, now points 1, 2, and 5 will go to the first cluster, and point 0, 3, 6, 7, and 8 go to the second cluster. But here the overall cost is 22, which is too higher than the earlier one. So the cost of the new cluster is very high compared to the earlier one. So then we reverse the swap and we stop the process. So this is the idea behind K Medoid algorithms. Let us see the advantages of K Medoid algorithm. It is very simple and easy to understand, and it supports fast convergence, and it is not sensitive to outliers. The problem is it is suitable for the normal non-spherical data. So it is not suitable for non-spherical or data objects. and it produces different results, okay, for different runs, even though we are using the same data sets. Look at the important points that differentiate K-means algorithm and K-Medoid algorithms. First one is complexity. The complexity of the K Medoid algorithm is a little bit higher than K means algorithms, and it is K Medoid algorithm is less efficient, and K Medoid algorithms does not require a convex form of data. And the most important advantage of K Medoid algorithm is it is not sensitive to outliers compared to the K means algorithm. Thank you for watching this video.